Alright, hello, one and all. You guys are officially in the game. In the game where maths is a game. You guys are inside Pagati. Inside where the game is maths and the maths is the game. Alright, guys, so today I'm just gonna get us warmed up. Yesterday night, we actually got warmed up doing some algebra equations, inequalities, and the simultaneous equations. So today gonna slightly take a turn here, and we are going to look at some exponential equations mingled with nature of roots. And then after we've done that, we're gonna look at maybe some functions, so that we can get functions rolling, if you know what I mean. Yeah, nature of roots, often underrated, but it does basically come to bite people when they have slept or have not taken that section a bit seriously. So yeah, that is just for that. So let us just wanna see if we can't extend them invites to people that are relevant, maybe that they can join in. Okay, so let us just say for a moment that we have 3x to the power half minus 5x to the power quarter minus 2 is equal to 0, and the question is saying solve for x. Alright, do we see what is basically being given to us in this equation, and can we quickly then sort of like take necessary steps to be able to then solve this particular exponential equation? Do we see what's before us, guys? Do we see it well? Right, 3x to the power half minus 5x to the power quarter minus a 2. Okay, hopefully we can see it, and we can see it very well. All right, yes. All right, so I just want to say that if we look at this middle term, it is negative 5x to the power a quarter. All right, this exponent half can be written in terms of this exponent a quarter, because what is a half? A half can be written as 2/4. Isn't that so? Right, so this is a typical situation where we can see that a quarter, if you multiply a quarter by 2, you will get a half, right? And if you divide a half by 2, you'll get a quarter, right? So hence we can rewrite a half to 2 quarters. Then you and I can rewrite that to become 3x to the power a quarter to the power 2, because a quarter times 2 gives me 2 quarters, right? Right, so I have a repetition of 1/4, right? X a quarter is repeated, x a quarter is repeated there, minus 2 is equal to 0. So just for ease, most learners then say let k be equal to x to the power a quarter. Why? Because that is a repeated variable. All right, so in this we can use the k method. K is the way that leads us to finding X, right? So this is one of those situations where we employ the K method, right? K is the way to solving for who? For X, all right? So I just want to re-look at this again. When you have a exponential equation where your exponents are rational, 3x to the power half minus 5x to the power a quarter, right? And then a constant term on its own equal to 0. What you have to check is, do we have a 2 times relationship between the rational exponents? So a quarter and a half. The 2 times relationship I'm referring to is which one do we multiply by the other by 2 to get the other one. So for instance, if you look at a quarter, if you multiply a quarter by 2, that will give you 2 over 4, which is a half. Okay, so multiplying a quarter by 2 gives me 2 over 4, which is a half. But when I multiply the half by 2, it gives me 1. So which one, when I multiply by 2, gives me the other rational exponent? Multiplying half by 2 does not give me a quarter, but multiplying a quarter by 2 gives me a half. So that then says to me that there is a relationship that exists between this rational exponent and that one. All right. So since a quarter multiplied by 2 gives me a half, I'm going to retain x to the power a quarter, and I'm going to manipulate a half. Now, a half can be written as its equivalent fraction as 2 and a quarter, 2 quarters. A half can be written as 2 quarters. Okay, so please repeat neo-dominus. Neo-dominus, I'm saying if you are given a exponential equation where you have rational exponents. By rational exponents, you can see there's fractions, a half, a quarter, okay, for each variable x, for 2 different terms. Then there's a third term which is on its own, it has no alphabet or x next to it, it's a constant term. You need to check between the quarter exponent and the half, which one of these two do I multiply by 2 to get the other one? Which one? Do I multiply half by 2 to get half? I mean, do I multiply a quarter by 2 to get half? Or is it that I multiply a half by 2 in the numerator to get a quarter? Is it a quarter multiplied by 2 in the numerator that will give me the other one? Or is it a half multiplied by 2 in the numerator that will give me a quarter? So let's check that. Guys, multiplying a quarter by 2 gives me 2 quarters, which is, when I simplify it, it is a half. So it is this direction that I am basically going to approve. But multiplying a half by 2, guys, it gives me 2 over 2, which is 1. So this here is not what I am going to go for. So since I know a quarter gives me a half, then that means I keep the variable x to the power a quarter as it is. But then I have to then change x to the power, especially the exponent half. I need to change that to a fraction that has the same denominator as 1 over 4. And obviously, half will then be changed to an equivalent fraction that has a denominator of 4. So what do I basically multiply 2 by to get 4? I multiply it by 2. So what I do in the denominator, I do in the numerator. So I have 2 quarters. But this can be rewritten, 2 quarters can be rewritten as x to the power a quarter. Then in brackets, you just have the 2 multiplied by 2. So this is 2 of my x quarters. All right. And you can see that there is a general repeated variable with its rational exponent of x to the power quarter for the first term and the second term. Then what I do for myself to make life then manageable that much more, I am going to use what I call the K method. Yesterday, when I was doing solving equations, I used the K method in a situation where there was a repeated expressions in my equation which lead to an equation of x to the power quarter. Because an equation of x to the power, sorry, not an equation of x to the power quarter, an equation that's x to the power 4. Because solving an equation with x to the power 4 is something that I don't have knowledge as to what to do. So we use the K method because there were 2 terms that had repeated expressions. We substituted k, then that allows us to solve for k first, then substitute back what we had let k be, and then solve for x. So K method simply means k is the way to finding x. So we are going to let k be the repeated, what is the repeated? The repeated variable rational exponent. The repeated variable, by variable we mean the space x, rational exponent we mean 1 over 4. So in that place of x to the power a quarter, we are going to substitute k. So we say 3 followed by who? In the place of x to the power quarter, we write k squared minus 5. In the place of x to the quarter, 5k minus 2 is equal to 0. Now guys, we have something very familiar, a quadratic equation that has a coefficient of k squared that is greater than 1. Okay, so there are many methods that we can apply. You can use the quadratic formula. You could basically factorize, okay, using the trial and error method. You could use the AC method. You could use any credible, solving for the unknown variable for a quadratic equation. Any viable method will be fine. So I personally can see factorization happening here because 3k and k will give me 3k squared. Okay, 3k times k is obviously your 3k times k is 3k squared. To get the negative 2, it will be 2 times 1, the factors. But then I need to be strategic about where I put my 2 and my 1. I'm going to be deliberate about making this become negative 2 because 3k times negative 2 will give me negative 6k. All right, that negative 6k, if I put 1 here plus 1, that means 1 times k will be positive 1k, and that will give me that middle term of negative 5k. So I would say these factors, they work out very nicely. Okay, so factorizing a trinomial where the coefficient of k squared is greater than 1 can be done using the trial and error method. You can use any method that is viable. Remember guys, there's also basically the quadratic formula, which makes life very easy. You'll just have to be very careful that since the variable is k, don't put x, you put k because it is the subject of the formula that you need to find the values of k. So you say k is equal to minus b plus minus the square root of b squared minus 4ac over 2a, and then you would substitute a, the b, the c into this formula, and it will lead you to getting the actual k values. So obviously after factorizing, we apply the zero factor law. which is you take 3k plus 1, equate it to 0. You take 3k minus 2, you equate it to 0. Then you solve these independently. Take the 1 over, you get negative 1. Divide by 3, you get k is equal to negative 1 over 3. Or k minus 2, you transpose the negative 2, you get k is equal to 2. Now one will think that they are done, but we are not done because we've just found the k values. Remember, k is the way to getting x. So now since we have our k values, we go back to the let k be equal to, what did we let k be equal to? X to the power a quarter. How many k values have we found? 2 of them. So we're going to say x to the power a quarter is equal to negative 1 over 3, or x to the power a quarter is equal to 2. Are we together, guys? I hope we are really together here. Now that we are here, listen and listen well. The rational that we have is 1 over 4. The numerical value that we have here is a negative 1. We know that when the numerator of our rational is odd, it's an odd number, but the denominator is an even number. And on the other side, we have a negative value. We can conclude from the get-go that there are no valid solutions. Okay, x to the power a quarter cannot give us negative 1 over 3. Here, guys, x has no real solution because there's no value that you can substitute in the place of x raised to this exponent, which will bring out a negative sign. So x has no solution. Let's just recap on the condition. If your variable has a rational exponent and number in the denominator is odd, this one is even. And then on the other side, there's a negative number. That simply means x has no solution. But let's go over this side. X to the power a quarter is equal to 2. Here, we can definitely solve for the equation. How? By using the reciprocal of 1 over 4. We multiply by the reciprocal of 1 over 4, which is 4 on the left. What we do on the left of our equation, we do on the right. What is a quarter times 4? That gives us 1. What is 2 to the power 4? That is equal to 16. Right? So our rational exponent here is odd in the numerator, even in the denominator, and there is a number that is positive on the right side. That means we are going to only possess or have one solution arise from this condition that we have here, which is why when we apply the reciprocal of a quarter on the left, we apply the same value of the exponent at the top for the right, and then we get 2 to the power 4, which is 16. So x, the only x value that is viable is that x is equal to 16. This, guys, is how we solve a rational exponential equation of this nature. Okay, so if there are any questions that you guys have in the comment section, you're more than welcome to ask those questions. If there be gifts that you want to send, I welcome roses, I welcome ice creams, I welcome anything that you personally think would be appropriate for this situation. Galaxies, the works. If you want to leave a comment in the comment section, comment. If you want to express your dissatisfaction, express it. I just want people to be engaged and to also communicate if there's anything that is there. If there are people that you think would benefit from being in this live lesson, share the live with them. Right? We'll be rocking this until 12, just a little bit after 12, and then I'll be going to bed. The next question that we are going to look at is one that pertains to nature of roots. And I want us to come here and look at this very quickly. Nature of roots. An often overlooked topic that people don't take very seriously, but one that subtly comes in. A question or two comes in there, so we just need to know the theory. Roots. Nature of roots. Learners must learn the theory of nature of roots and should be able to apply it within the context of the quadratic formula, as well as integrated into your functions. Nature of roots, guys, is not something you just need to know just for the sake of knowing nature of roots. Nature of roots, guys, what is a root? Okay, a root, guys, is a solution that you get when you are solving any equation. The minute you write that solution, whether the equation be in terms of x or a or b, but the minute you write the solution, therefore x is equal to, that is a root, right? But now we need to know or learn the theory of the nature of roots and should be able to apply it within the context of quadratic formula, as well as integrated into functions. So you must know how to apply that in both contexts. Quadratic formula, which is you use quadratic formula whenever you want to solve for an equation. Functions. Well, what ties roots to functions? It is your x-intercepts, because roots are actually x-intercepts in functions. Where you let y be equal to 0 is how you find your x-intercepts. Learners should know how to find, what is this, guys? What does the symbol stand for? Do we know? Equal to b squared minus 4ac. Do we know this? Do we understand it? Do we comprehend it? Makes sense to us? Do we know what the concept basically entails? All right. Do we know what the symbol basically means? Do we know what this b squared minus 4ac helps us with? All right. So we call this delta, and we say b squared minus 4ac is the expression of delta, which we also refer to as the discriminant, because it is the one that helps us to make a clear judgment about what is the nature of a particular root, or what is the nature of particular roots. Now, we need to be able to state the nature of roots of the given equation when delta is equal to 0. What do we know when delta is equal to 0? The minute we find out that delta is equal to 0, or the discriminant gives us a 0 value, then we conclude the following: that the roots are equal, the roots are real, and the roots are rational. Why are they equal? Because delta is equal to 0. Why are they real? Because 0 is a real number. Why are they rational? Because 0 is a perfect square number. What is 0 times 0? It is equal to 0. So since 0 is a perfect square number, it means that the roots are rational. Okay? Moving right along. What about when delta is greater than 0? But at the same time, it is not a perfect square. If delta is greater than 0, but at the same time, it is not a perfect square, this is the conclusion that we get to reach by knowing that delta is greater than 0, but not a perfect square. An example would be if, let's say, delta is equal to 50. The number 50 is not a perfect square. So what can you conclude if you get an answer of delta is equal to 50? Since 50 is not a perfect square, you can conclude the following: the roots are real. Of course, the roots are real because 50 is a number that is greater than 0. So you say the roots are real. 2, the roots are unequal. In other words, those roots are not the same. 3. Since 50 is not a perfect square number, we can then make the conclusion that our roots will be irrational. Moving straight through. When delta is less than 0, what do we know? We know that the roots are non-real. When delta is what? Less than 0. We know that the roots are non-real. There's only one basic, straightforward conclusion. When delta is greater than 0, the roots are clearly just non-real. Let me also then turn our attention to the functional representation of when delta is equal to 0. What can you basically see in a diagram where you have a parabola sketched and it is a function on the Cartesian plane? When the roots are equal, guys, this is the expected parabola that you can expect to get. A parabola that simply touches the x-axis once on the x-axis, meaning there's only one root, one x-intercept. The x-intercept is also the turning point. That's a representation graphically of what delta is equal to 0 actually means. If you are speaking about a graph, just one root. Or it could be concave down the parabola touching once. That also means delta is equal to 0. Graphically, that's what you mean by when you're saying delta is equal to 0. We are saying that the roots, which are also what? The x-intercept, we are saying that they are equal. Okay. 2, they are real. 3, they are rational. What about delta greater than 0? Graphically, delta greater than 0, where the particular value of delta is not a perfect square. What do we see graphically? We will see something like this. Roots are different, okay? But those particular roots or x-intercept, remember roots are also called x. This is another, when we look at functions, roots are what we call x-intercepts. What about them? They are real, meaning they are actual real numbers. 2, they are unequal, meaning they are not the same. You will have one root this side, one root on the other side. They are unequal, meaning they are not the same. 3, they are irrational. Guys, those x-intercepts will actually be irrational numbers. For instance, this root might be square root of 3, whereas this root will be, let's say, negative square root of 2. So let's say this root is negative square root of 2, this root is square root of 3. Do you see that these two numbers are actually, or these x-intercepts, they are actually irrational? At the same time, are they the same? No, they are unequal. Also, they are real. What does the word real mean? Guys, what are real numbers? Real numbers are all the numbers that are found in the number system, both rational and irrational. So if you are saying your roots are real, you are just merely saying they are existing numbers in the number system, but they are specifically not just rational, but they are irrational. Okay. TNT, please, if you need a break, you can leave the live. Okay. The we part, I think you are speaking for yourself. I appreciate your comment, but yeah, you can take a break, my dear. All right, I will post this live lesson, the video, on the YouTube channel. The link is in my bio for the YouTube channel, so that when you have time, you can watch on your own time. Okay, yeah, because people are writing in May and all of these things. So yeah, this is just a merci beaucoup, if you know what I mean. Yeah, for roots, nature of roots. Just trying to remind people of important aspects in these things, right? So if you are a grade 11 learner, this is key. If you are grade 12, it's even more key, because when you should be knowing all the content. If you are writing in May, June, this thing, you should be knowing all of this. All right. So the people who are complaining, you are crying in the comment section, remember, your tears, they are not falling on deaf ears. That's why I am here. Okay. So I'm just trying to, for those that don't know or may have forgotten about nature of roots, I'm trying to recall for you, so that you can be reminded of key things. Are we together? Yeah. So if it's too fast, remember, some of you should know this thing. I'm bringing certain things that you should know to your remembrance. Yeah, you see. So yeah. Anyways, let me continue. So I was saying that when delta is greater than 0, and at the same time it's not a perfect square, the value of delta is not a perfect square. Like for instance, delta is equal to 50. That 50 is not a perfect square number. Then we can conclude something about the roots, and that is the roots are real. Of course, they are real. They are unequal, meaning they are not the same, and they are irrational, meaning if you were to look or see the roots, you would see two roots, meaning two x-intercepts, but both of them would be like square root of 3 is an irrational number. Negative square root of 2 is also an irrational number. You would see that the x-intercepts are actually irrational numbers. In other words, the roots are irrational. Because remember, roots and x-intercepts are one and the same thing. All right. Now let's look at when delta is greater than 0, but at the same time it's a perfect square. Delta is what? Greater than 0, but this time it is a perfect square. What would be the difference? Well, this is the difference. The roots are still real, just like they were real for the ones above. The roots are still unequal, just like they were unequal for the ones above. The only difference is that because delta is a perfect square, perfect square speaks to the roots being rational. The fact that delta is a perfect square, it speaks to the roots being rational. But remember, for the previous case, when delta was not a perfect square, it speaks to the roots being irrational. So these are important things to note. If delta is greater than 0 but not a perfect square, the roots will be irrational. But if delta is greater than 0 and it is a perfect square, the roots will be rational. Okay? Yeah. So an example of something that is a perfect square would be like when delta is equal to 25. 25 is a perfect square number, guys. So that then means that graphically, what is something you can expect to see if you are looking at rational? Okay, you are going to have two unequal roots. In other words, two unequal, meaning not the same x-intercepts. But when you see those x-intercepts, maybe one is 4, the other one is -3. -3 is a rational number, 4 is a rational number. So that's why we're saying that the roots, both of them, they are real. -3 and 4 are real numbers. 2, -3 and 4 are not equal, they are unequal. 3, -3 and 4 are both rational numbers. Because what is the definition, guys, of a rational number? It's a number that can be expressed in the form of A over B, where A and B are both integers. In other words, the numerator and the denominator are both integers. What are integers? Integers are positive and negative numbers that are complete. like 0, 1, 2, 3, -1, -2, -3. Those are integer values. So the numerator and the denominator should possess integers. But we know that your denominator, b, can never, ever, ever be 0. You can't have a 0 denominator, because the minute there's a 0 in the denominator, we do no longer have a rational number. We have an undefined number. Okay? Yeah. So this would be can you hear these people singing? So irritating. So irritating. So irritating. Why don't you strike with other students? These are not students that are striking. These are students that are enjoying their Friday night, you know. So there's no strike happening. It's more of like they are guijorizing and enjoying their Friday night. So yeah, because I'm in a varsity town, varsity city, if you want to call it that. Anyways, guys, delta greater than 0 and is a perfect square. This is an example of what you would see graphically. Delta greater than 0 and not a perfect square. This is an example of what you can expect to see graphically. It's an example, guys, okay? Yeah, it could be a concave up graph, it could be a concave down graph, but your roots, your x-intercepts, your roots will be irrational when delta is not a perfect square. But when delta is a perfect square, your roots will be rational. Okay? Okay, and lastly, when delta is less than 0, we say that the roots are non-real. Now I want to show you graphically what do we mean by when delta is less than 0. Graphically, guys, you have a parabola that is basically floating. It's floating. It's floating. Why is it floating? Non-real, meaning it has no real roots. In other words, there are no x-intercepts. No real roots, no x-intercepts. That's why this graph does not cut through the x-axis at all. And this one as well is not cutting through the x-axis at all, because it possesses no x-intercepts. It has no real roots. So when you solve for that particular function's x-intercepts, you find that you cannot find any x-intercepts. Your calculator will say maths error when you try and find using the quadratic formula, because there are no real roots. Okay, that's what delta less than 0. That's when you get a delta value that is negative. Then you say one thing, the roots are non-real. Finished, full stop. Graphically, this is what you will see for non-real roots. Okay, yeah. Now people don't understand these basics. Then they struggle with functions, especially when it comes to the K type questions. You know, for which values of f of x plus k is equal to 0? For which values of f of x plus k will you have two positive real roots? So these are questions that basically people are unable to answer because they don't understand nature of roots. We're going to look at some examples now, different types of questions, so that we can see how do we approach questions. Now, understanding these concepts, let's see how do we approach different questions pertaining to nature of roots. These are exam type questions that I'm going to be looking at, so just pay attention and follow along. Hopefully, if you have any questions, guys, you can see there's mark allocations for this. No by heart, bro. Guys, that's beautiful. Lena must know the above conditions by heart. I'm telling you, by heart. By heart. All right. You know what's interesting? Things that people know by heart. You know, it's like, for instance, I will say, look, check this out. Angwas no te, angwas no la. And God's no, and I say to you, complete the statement. All right. I'm sure you can hear the particular, that there is a particular thing that I'm actually doing. Ankwas no la la, ankwas no, and I say finish the rest of the song, if you will, and maybe accompany it with a specialized dance that accompanies that. All right, you will be shocked how many people can do that because they know by heart. Yeah. Right, I will sing a song from long time ago. I will start it off, a popular song that was sang maybe 2 years ago, or maybe it's an artist that long past, but it's a popular song. I will start singing it, and you will see people sing along. Why? They know by heart. So what are the things that we know by heart, and how many things are unimportant for life do we know by heart? People will know by heart the things that they value the most, the things that they prize the most. Some of you are rewriters. You are rewriting your maths papers in May. Why? Because you want to do a turnaround in your career path. You need that 80%, 85% for mathematics so that you can go and access opportunities in university that have to do with studying for a particular course that you want, because you want to turn around your career situation. So is there things that then are worth knowing off by heart, since you'll be writing very soon? Definitely, man. And most of the things in mathematics, if you don't know them off by heart, what happens is that, I don't care what great teacher you have, that teacher can teach you all they want, but if you don't understand those things and don't know them off by heart, it's going to sabotage you. So let's look at this question. Without solving the equation 3x squared plus 8x minus 2 is equal to 0, discuss the nature of its roots. So here they don't want us to solve the equation. In other words, they don't want us to take this equation and go ahead and solve for the roots and then from there comment on the nature of roots. No, they are saying without solving the equation, let's go ahead and discuss the nature of its roots for 5 marks. So the question then is, how do we discuss the nature of the roots of a particular equation without solving it? That is the question you want to ask yourself. Okay, I understand, my guy, and I appreciate you. The reason why you went back all the way to addition and subtraction, I love you for that. Yeah, you start from there, you build. You will see how amazing you'll be in maths, because once you understand the basics, it's amazing what else becomes easier to learn as you go along, step by step, my guy, step by step. Keep it up. So how do we solve an equation? How do we solve this particular question? How do we discuss the nature of these roots without solving the equation? Here is our guy. We use delta. So feast upon the method as I answer this question. You first write down the equation 3x squared plus 8x minus 2 is equal to 0. 1. Make sure the equation that you have is in the standard quadratic form. This is the standard quadratic form, guys. Ax squared plus bx plus c is equal to 0. Is this equation in the standard quadratic form? Tick, yes. Step number 2, identify A, B, then C. So from here, in the standard form of the equation, we need to identify A, B, and C. Where is A? It's the coefficient of x squared. Where is B? The coefficient of x. Where is C? It is the constant term. Don't be afraid, guys, to access your gift gallery and gift me. I'm not opposed to gifts, guys. Yeah, because I see some of you want to, but it's like you're holding back. No, don't be scared. Identify A, B, and C. So A here is equal to what? B here is equal to what? C here is equal to what? Can you guys tell me what A is? Comment section. Let's write down the values A, B, and C. I want to see if you guys know the values of A, B, and C. Use the comment section for me and tell me what A is, B is, and what C is. Because that's the second step after writing the equation in standard form. This is already in standard form. No Z, no Z, no Z, no Z and Lelo. My goodness. Oh, we've got a white rose in the house as well. So A is equal to 3. Nozi, Lelo, and white rose agree. Thank you so much, guys. Lelo and Boypelo are saying B is 8. Very good, guys. Lelo and Bondle are saying Lelo is saying C is negative 2. Bondle is underscoring A is equal to 3, B is equal to 8, C is equal to negative 2. Nozi is underscoring that as well. So basically, I think we have a shared consensus. A is equal to 3. It is a positive value, so that's why it's positive 3. B is equal to 8. It is a positive value, so that's why we write 8. C is equal to, now the constant is not just a positive value, it has a negative sign. So we say C is negative 2. That is step 2. Step number 3. Delta is equal to B squared minus AC. We substitute into that. Delta is equal to B squared minus AC. They identified A, B, and the C. Let's go ahead and do that. In the place of delta is equal to B squared minus 4AC, we substitute the identified B, A, and C using brackets. Please, guys, do not omit to use brackets. So we put in the place of B 8, we square 8. We put in the place of A 3, brackets. We put in the place of C negative 2, put brackets. What's 8 squared? 64. What's a negative times a positive? That is a negative. Then what's a negative times another negative? It is a positive. So we are saying positive. What's 4 times 3? 12. What's 12 times 2? 24. And no Z has the answer for us in the comment section together with white rose. Delta is equal to 88. So 3, we substitute. 4, get value of delta after simplifying. Hey guys, and when we simplify, let's not forget the 3 dangerous letters that appear in our television screen for all the movies we shouldn't be watching. S, you know what S stands for the movies you shouldn't be watching on TV. N, you know what N stands for all the movies you shouldn't be watching. L, you know what L stands for. And if you've been in my live lessons for too long, you should know what S and L actually stand for in maths. You make sure that you multiply your signs properly, you multiply and your numbers properly, and then if they are letters, you would multiply letters, but they are not. So please, guys, make sure that your multiplications of signs and numbers is 100% accurate. Hence, I'm saying this here gives us positive 24. 8 squared gives us 64. The addition, we apply BODMAS properly. Oh, guys, multiplication happens before we add numbers, you see. And BODMAS says brackets, you see. So that's why we put things in brackets. O means orders, meaning exponents and roots. The exponent must be applied to the number 8. Then D, division, there's no division. M, multiplication, yes, multiplication we sort out. Then addition and subtraction come later, hence the addition comes later. Diba, what's the problem? Say if, what's the ... for? Delta is equal to 88. Number 5. Tell us about delta first. Since delta is equal to 88, there are 2 things. Delta is greater than 0. Why are we saying delta is greater than 0? The number 88 is a number that is bigger than 0. Secondly, delta is not a perfect square. Why are we saying delta is not a perfect square? 88 as a number is not a perfect square number, guys. 88 is not a perfect square number. The thing is, I know my perfect square numbers well, off by head. These are the things I know off by heart. This is part of the off by heart stuff you should know. When you are in the school system, grade 8s should know all the perfect square numbers off by heart. Grade 9s in maths should know all the perfect square numbers off by heart. So by the time you get to grade 12, that should be in the system, in the head, in the mind. It should be your daily bread. So when you look at the number 88, you can see, it's not a perfect square number. It's this number. Then that's all you can say about delta. 5, 6. Now comment on the nature of the roots based on delta. Based on comment number 5. Comment number 5. Delta greater than 0, delta is not a perfect square. That means the roots are 1. Real. Why are we saying the roots are real? Anything that is greater than 0 or equal to 0 speaks to the roots being real. 2, are they equal or unequal, the roots? When delta is greater than 0, that says the roots are unequal. But if delta was basically equal to 0, we'd say the roots are equal. But when delta is greater than 0 alone, we say the roots are unequal. Lastly, because delta is not a perfect square, we say that the roots are irrational. This is the nature of the roots. The roots are real because of delta greater than 0. The roots are unequal because of delta greater than 0. The roots are irrational because delta is not a perfect square. Everything that we are commenting about the roots is coming from something we have indicated after getting the value of delta. Okay? They are irrational because delta is not a perfect square. They are real because delta is greater than 0. They are also unequal because delta is greater than 0. So the basis for real and unequal comes from delta being greater than 0, and the basis for the roots being irrational comes from delta being not a perfect square. So that's how you answer that question. Any questions? Clear? Clear as daylight? Hey, 1 mark for substitution into the formula, 1 mark for value of delta, 1 mark for your extended comment on delta. These two things, very critical. Delta greater than 0, delta is not a perfect square. 1 mark for concluding about the nature of the roots without having to solve. Okay, yeah, so that's basically what we do. I see Tiba is saying there, can you help me with the question that I've seen? Is it pertaining to nature of roots? You need to clarify that for me in the comment section, because I don't want to deviate. All right, if it is a question on something else, then you can actually send it to me, and then we can talk about me potentially doing that next time. Or yes sir, so it is on nature of roots. Just confirm that for me. Say yes sir, it is on nature of roots. Or you have that, or you have it there. Okay, so you typed it. Oh, okay. How can we express the roots of the equation in terms of n? Diba, here you take that equation, you solve for it. It's already in standard form. 9x squared minus nx plus 49 is equal to 0 is already in standard form. So to make life very beautiful and easy for yourself, what do? You just grab the quadratic formula, you substitute into the quadratic formula. A will be 9, B will be negative n, and then C will be 49. You substitute into the quadratic formula, you simplify the expression on the right hand side of x. Simplify it so that you can then represent your roots in terms of n. N will be on the other side anyways, so your answers will be in terms of n. That's how you do that question. That's how you express the roots. What are roots? Roots are the solutions of a particular equation. All right. So that's how you do that one. Use the quadratic formula. Straightforward. You've used the quadratic formula. Straightforward. Show that the roots of the equation x into x minus 3m is equal to negative 5m squared and non-real if m cannot be 0. Show. So this question is a show that. This one was a discuss the nature of roots, but this one is a show that. A show that question is done in the very same way that we have just done the previous question. Okay, sometimes guys, they don't say show that, they will say prove that. The method is the same. The only difference with show that and discuss the nature of roots is that in discuss the nature of roots, most cases your delta is equal to a number. Then you comment on delta and then the roots, how they are. In the prove that or show that questions, when you get to your delta value, it is not just a numerical number. It is actually a expression, an algebraic expression in terms of m. You're going to see what I'm talking about. But let's read this. It says, show that, you could also say prove that, the roots of the equation x into x minus 3m is equal to negative 5m squared are what? They say we need to show that they are non-real if m cannot be 0. We need to show or prove that the roots of the equation x into x minus 3m is equal to minus 5m squared are what? Are non-real. On the condition that m is not ever going to be 0. So let's first do what? Let's take this and write the equation in standard form. Then after that, we are going to identify a, b, and c, substitute into delta or a, b, and c, see what we get as our value of delta. It's not going to be a number this time round, but an expression. And then we'll see, you'll see. So let's write first that equation. That's the first step, was x into x minus 3m is equal to negative 5m squared. This is the given equation. What we are going to do, we are going to write it in standard form. Take the x, because x into x minus 3m, we can apply what we call the distributive law. Okay, x variable we distributed inside the bracket because there are two separate terms. What's x times x? X squared. What's x times minus 3m? Negative 3xm. You take the negative 5m squared, you transpose this. It is negative, so it becomes positive 5m squared is equal to 0. What have you just done? You've gotten the equation to be in standard form. That's step number 1. Get the equation to be in standard form. Ax squared plus bx plus c. Now some of you are like, but sir, this is not a constant term. It does not have just a number alone. Well, the main character variable is x. So that means any other variable, guys, is basically going to take the place of a coefficient. All right? And a constant if it is standing alone. So for here, for instance, you want to identify a. What is the value of a? Now you need to tell me. Let's see you people do the same thing you did. I want a, I want b, I want c. Let the comment section be ablaze with the answers. I'm waiting for Nosy. Nosy, I'm waiting for you. A is equal to Bontle. You beautiful person. Yes, Bontle. A is equal to 1. Knows yes, A is equal to 1. Bontle, B is equal to -3. Now, Bontle, be careful this time round. Do you remember what I said? X is the main character variable. So now when we identify the B and the C, we need to regard the other variable that is not X as if it is a numerical number. All right. We need to consider or regard the other variable as if it is a number. So it will basically take the position of a coefficient if it is part of the X term. It will basically take the position of a constant if it is basically accompanying a numerical value alone and there's no X. Okay? Neo dominus clips. A is equal to 1, B is equal to 3m, and C is equal to 5m squared. Neo, you are nearly 100% correct. There's something that is off about one of your values. Your A value is 100% correct. Your C value is 100% correct. Your B is missing a very fundamental aspect to it. Right? I think once you correct that, then I'll be like, very good, Neo. Otherwise, you are literally more than halfway there. Keith has just basically said you should have put a -3 there in the place of 3, not just 3. All right. So Keith, I hope you are just adding that aspect of negative. But all in all, A is equal to, as you have said, my beautiful people, it is 1. Coefficient of X squared that you can't see, it's like God, unseen but present, all right, is 1. B is -3m. So -3 and m play the role of the coefficient of X. So that's our entire B thing. Remember, I said to you that in this situation, X is the main character variable. The other variable that is featuring there, we don't regard it as a main character variable. It is a supporting cast. Since it's a supporting cast, it becomes part of your coefficient in the middle term, and it becomes part of your constant for the isolated numerical value. So C is positive 5m squared, my beautiful, wonderful people. I hope you now understand, and you understand well, because lacking understanding in this aspect leads to frustration, loss of marks, and basically I don't know what else. All right. Or what? The main character variable? X. It's the steering. He's the one that comes and saves the day. X is the Superman of this story. M, you might think is the Superman of the story, but he's not. M is simply a supporting cast. So you must then include it as part of your coefficient, and you must include it as part of your constant term. Are we together? I hope you are feeling me here, guys. Once you feel me like this, you will. Also, when you are doing maths, angwas no lala, angwas no teba, siviribi yo, e-maths ya pasa, bye. So please, guys, just, maths get pasa me now. Okay, so now we go to b squared minus 4ac. We go there to that delta. We substitute there in that delta. B -3m. We square the entire thing. All right. Minus 4. A is 1. C is 5m squared. You see, nature of roots, beautiful, guys. Then we apply BODMAS. -3m squared. Remember now, exponents say when you have a multiplication of a coefficient and its variable, the exponent gets applied to the sign. Here, S and L, the sign, the number, the letter. The sign, the number, the letter. You square a negative sign, you get a positive sign. You square the 3, you get 9. You square the m, you get m squared. You only do this when the coefficient and the variable, there's only one term inside. Okay, but if there were two terms, we'd open two brackets and we'd do what we need to do, multiply out. Okay, then negative 4 times 1 is negative 4 times 5 is negative 20. Negative 20 what? M squared. All right, then what's 9m squared minus 20m squared? I but we are seeing like terms here. Hey my daughter, that's using our 9m squared minus 20m squared. We got 9m squared minus 20m squared, guys. So there we can now subtract these like terms. What do we get? Tell me in the comment section. Let's see what you guys get. Your answer, 9m squared minus 20m squared is equal to what, guys? Nosy. Are you sure? Bango 11. Just 11. Kaloku, if you are saying it's 11, you are saying it's positive 11, my dear. Alright. Thank you. Bontle and Kazi and Case are fixing the sign of the 11. Remember, when we add and subtract like terms, we keep the variable and its exponent, because that's what makes it like terms. Like terms are like two kids they are like kids in the same school wearing the same uniform. The m squared and the m squared are like the uniform. When you add and subtract the kids, that uniform does not go anywhere. You are just affecting the number of the kids. So 9 minus 20 is a negative 11. Let's go back to the question. What did it say? Show that the roots of the equation of this are non-real if m cannot be 0. Guys, let's just now explore this. If m cannot be 0, if m was 0, this would be 0 squared, and then 0 squared is 0. 0 times a negative number would give us a 0. Then we'd have delta is equal to 0, which means that the roots would be equal. They would be real. They would be rational. But what they are saying here is that show that the roots of this equation are what? Non-real. But only if m is not and cannot be 0. Show that the roots are what? Non-real. Now please take note of something here. Delta is equal to negative 11 m squared. Now we can say delta is less than 0 if m cannot be 0. Think with me here. Think it through with me. I have accepted that my delta value is going to be negative 11m squared. You remember I told you guys, I said that for show that and prove that, in most cases you get an expression in your answer for delta. But this expression will have a variable, not the main character variable, but the supporting cast variable. All right. Now, if the m is never 0, it means that m can either be a positive or a negative number. It can be any other number as long as it's not what? 0. That then means you could test any positive number. Let's say you test 5. And then let's change it up and say we test negative 5. Tina, what do we know? Whenever you square a positive number, you get a positive number out of it. That positive times a negative, doesn't it always give you a negative answer? The answer is it does. If you take a negative 5, it's inside the bracket, and you square it, it will give you a positive answer here. Doesn't a positive times a negative sign give you still a negative answer? I think you see that it does. So our delta value is forever going to be what? Negative. That is why I am saying to you that delta is going to always be less than 0 as long as m is not equal to 0. Any other number you substitute here in the place of m, you are going to square it and get a positive number. that positive number is going to be multiplied with a negative sign or negative number, and that negative number will give you a negative outcome. A negative outcome, meaning delta is forever going to be less than 0 as long as m is not 0. Guys, are you hearing my explanation well here? For show that and prove that, you get a expression that will have the supporting cast variable. That's the first thing. 2, they said in the question we need to show that the roots are non-real. Non-real kandu means what? That's when delta is less than 0. We are discovering here that delta is going to remain as being less than 0, meaning it's going to remain as being negative as long as m is not 0. Because guys, if m is 0, it makes delta be equal to 0, which means the roots are equal and they are real. We don't want that. So they've put this condition so that it safeguards and makes sure that delta remains as being negative. You substitute any positive value, you're still going to get a negative answer for delta. You substitute any negative answer in the place of m, you're still going to get a negative answer for delta. So delta is less than 0. I am concluding now that delta is less than 0 if m cannot be 0. So what does that then mean for the roots? The roots are non-real, full stop. The roots are non-real. And you thought we can't answer that question. We can. Show that or prove that. Thank you so much, A. I really appreciate your kindness there. I see you're generous. You awesomes. Bruh, you are awesome yourself for being so kind and unleashing the gifts. In the middle of the night, in the middle of the night, I go doing maths in my sleep. Thank you so much. Really appreciate it. You are too kind. Generosity. I appreciate your generosity. I saw even above, like before these 4 you awesomes, there were others. Thank you so much. You're too kind. All right. Let us now proceed to the next question. Okay, we're still on nature of roots, guys. Consider the quadratic equation kx squared minus kx is equal to 2. Now, I always do these lessons 10 after 10 because that's like literally when I can actually settle down and do some. So I know it's late. I know some of you are pretty much drowsy, probably had a long hectic day at work. So please, I do upload these lessons on my YouTube channel. Find the link in my bio. You know, last night I was here, I was doing equations, inequalities, simultaneous equations, k factor kind of things, and the functions. I did, a bit of that yesterday. And the live lesson that I had basically done, I uploaded it on my YouTube channel. 3 hours, because I think I started at 9 and I ended literally at 12:30. So that was a lot of hours, guys. So you can check those out, those previous sessions that are previously done. Okay, find the link in my bio. It's also called Maths as a Game. The profile picture in the YouTube channel is the same as this TikTok profile picture that you see. It's easy, just go to my link in my bio. You click on the link in the bio, it will send you to the YouTube channel. Subscribe, please, guys. More support there. Please go and just harass my videos. Comment, even if you just comment your videos are poor, like get your quality right, just comment something, man. Go like or go unlike, whatever you need to do. Just, it's nice if I get activity in those in that channel, please, guys. It's really helpful. Okay, consider the quadratic equation kx squared minus kx is equal to 2. 4.3.1. Okay, I'll post this one too. Okay, show that the roots of the equation will equal. All right, there was a person that came onto my live lesson and asked a specific question. That specific question that he was asking is similar to this question I'm going to answer, because that question was saying determine show what did it say? Determine the roots in terms of n. If you remember, his equation was 9x squared minus nx plus something. I can't remember the specific equation, but then I said to him, guy, take the equation, okay, that his equation was already in standard form, and then I said to him, just simply use the quadratic formula, my guy. Yes, Kazi, it was plus 49. All I said to him, use the quadratic formula, all right, because you are going to get the equation in terms of n. You guys are angels. Look at Bondle just like copies the entire equation. So yes, this question here, this one, consider the quadratic equation, show that the roots of the equation will equal, all right, is the same question as this one, that 9x squared minus nx plus 49 is equal to 0. How can we express the roots of the equation in terms of n? You see, it's worded differently. For this one, the answer, how it's going to turn out, you are actually given how the answer will turn out. So all you need to do is the process, so that they can give you the marks for the process. They can give you the 3 marks for you showing the process, okay? But for the question that my guy was given, that he asked and he posted on the comment section with Bontle has been so kind to actually repost that question. There you are not given how the answer will turn out, but they are giving you the equation and they are like, you know, you need to basically showcase the roots in terms of n. All right, so here, right, because x squared is the main character variable and we have k, which is not the main character variable, it is the supporting cast, then it means our answer will be in terms of k. We are solving for what? For x, but in terms of k. Show that the roots, this word roots, guys, simply means the solutions of this equation, this one, okay? So what you do then in a question like this, this one is not asking us anything, there's nothing involved with delta. This question is simply saying show that the roots of the equation will equal this. All right, so let's go write first the equation that we're given. Kx squared minus kx is equal to 2. 1, get the equation in standard form. Let us get the equation in standard form, which means if there's a constant, we transpose it. The 2, kx squared minus kx minus 2 is equal to 0. This is our standard form. Okay, so standard form, we are fine so far, right? Then, after standard form, we identify A, B, and C. A, B, and C. Oh, can my people do what they know how to do best and identify the A, B, and C? I trust you. This time around, I think you learned the lesson about A, B, and C, especially when there's the main variable x and the supporting cast variables, which we know are simply coefficients if they are next to the main character variable, but they serve as constants if they are alone with no variable of x. Okay, so can you guys tell me what A, B, and C is here? A is equal to B is equal to C is equal to. Oh, nosy. Oh, nosy. Nosy. You see now when you've gotten it now. You've gotten the swing of things. Thank you so much. Very good. Gazi, beautiful. All right. Bondle, signs, my dear. Let's be careful about the signs. All right. I hope you can see basically Bondle, the sign thing. Oh, so A, you guys are 100% correct. It's K. Okay, 1K of course, but remember that even if we don't write the 1 is there. B is negative K. Please guys, negative K, supporting cast stuff. C is negative 2. It has no K, so it's negative 2, the numerical value on its own. Hi, now we are ready. Now guys, we don't go and write delta. No, remember, we want to show that the roots of the equation will equal this. There's no way you are going to get this if you're just going to write delta is equal to b squared minus 4. The only way you're going to get this is if you use the quadratic formula and solve. Okay, so quadratic formula, it's one of the formulas that are in the formula sheet, which we need to know off by heart. You know, minus b minus, is already there, the minus sign. The b value is negative k. We write plus minus. We substitute using brackets, please, guys. Always factor in your brackets when you substitute. Don't just substitute without placing in brackets. B is negative k. We open a bracket, we substitute, we write the squared outside the bracket. Minus 4, a is k. C is negative 2 over 2. A is k. Yeah, guys, I hope you will not just be satisfied by watching me do this. You must be there. Right? And the pace at which I'm doing a particular question should resonate. The mark allocation is 3 marks. I can't be spending, guys, during an exam more than 3 minutes answering a question like this. Okay, remember, if I want to have time at the end to go back and check what I have written down, then I must also be very, very much interested in ensuring that if it's 3 marks, let's try and spend a minute or so, right, answering that question. So writing the equation in standard form shouldn't take you long. Identifying a, b, and c shouldn't take you long. The quadratic formula is something you should know, but it's also in the formula sheet. Basically, guys, remember, there's a formula sheet. You make sure you write out that quadratic formula as accurately as it appears in the formula sheet, and then you do your substitution in brackets accurately as well. Now, don't allow yourself to put yourself under pressure and then end up making mistakes by substituting something that's not there. For instance, you say in the place of b, you write k, not negative k. You see, careless mistakes like that can cost you big time. Okay. Why do I use the quadratic formula? Gazi D. The question says, consider the quadratic equation. Show that the roots of the equation will equal. So what are roots? Roots are your solutions of a given equation. So this given equation has its main character variable. Its main character variable, all right, is x. Do we agree? So that's like the same thing as them saying solve for x, because if they are saying I must show that the roots will be equal to this, what are roots, guys? Showing that the roots will be equal to this is in other words saying show that your x values or your solutions for the equation will be like this. There's no way that your solutions will be like this unless you use the quadratic formula. You see, it's like b squared minus b minus b plus minus the square root of b squared minus 4ac over 2a. So something needs to give for you to have an answer like this. That's why we are using the quadratic formula. They are actually basically saying to us, solve this equation in terms of k. Solve for this equation in terms of k. Remember that question that guy posted in the comment section that he was saying, sir, can I ask you a particular question? And then I said to him, yes, you can. And then he posted his question, which was also reposted just now. That one also needs us to use the quadratic formula because they want us to get the solution or the roots in terms of n. And if you look at that equation, who is the main character variable? It's also x there. Who is the supporting cast? It is n. So that means we are going to get the equation, or we are going to get, the solutions or the roots of the equation in terms of n in that particular one. All right. So I think we are close now to the answer. Let's just make sure our signs and everything is correct. What's negative times a negative? It is positive. So that negative times a negative gives us a positive k. Plus minus is staying intact. What's negative k squared? That's k squared. Remember, an exponent that is even applied to a negative sign leads to a positive answer. K is k squared. Now, minus 4 times k times negative. Let's start with the sign. A negative times a positive is a negative. A negative times a negative is a positive. Then we move on to the number. What's 4 times 1 times 2? 4 times a 1 that you don't see there is 4 times 2 is 8. Then the letter k. S, N, L. You multiply the signs, you multiply the number, you multiply the letter. We get positive 8k over who? Over 2 times k, which is 2k. Sorry, I got a bit ahead of myself there. It is 2k. Now guys, do you see this? They said I must show that the roots of the equation will equal this. Haven't I just done that now? Isn't that k? Isn't that k? Isn't that plus minus? Isn't that plus minus? Isn't that the square root? Isn't that the square root? K squared plus 8k, k squared plus 8k, all over 2k, 2k. Isn't that x? Isn't those my two solutions? One being k plus the square root of k squared plus 8k over 2k, and the second one being k minus the square root of k squared plus 8k over 2k. Those are my two solutions, my two roots, as we call them, in terms. You see, k is on the other side. It's not just a numerical value. All right, so this is what they mean by show that the roots of the equation will equal this. So my guy that asked me the question in the comment section, I'm hoping that he was able to successfully get to the solutions for that particular question. Maybe you can even do that for yourself, my people there in the comment section. You could do that particular question that guy posted in the comment section and just see if you are able to maneuver and get the solutions or the roots in terms of n. Okay. So this thing of in terms of another variable means that variable needs to feature in your solution. So for that equation that young man asked, you will find that x will be equal to, but n will feature here because the answer is going to be in terms of n, right? Let's move on. 4.3.2, determine the numerical values of the roots if k is equal to 1. What are they saying now? We saw the roots in terms of k, but now they want the numerical values of the roots if k is equal to 1. All right, let's continue then. 4.3.2 is a continuation. These are the roots. All we need to do is we go to k, we go and substitute k is equal to 1 into the roots that we have found that are in terms of k. And then we should be able to get the numbers, the actual roots in numerical. When they say numerical values, guys, they are saying find x as numbers. Don't find x in terms of variables. Find x now in terms of the numbers. For how many marks? For 4 marks. So it's substitution and then getting the answer. So let's go and write x is equal to, in the place of k, faku 1, right? Brackets. In the place of k, faku 1 plus 8 into 1 over 2 into 1. Right? Then 1 plus minus 1, 1 squared is 1, plus 8 over 2. Then 1 plus minus, you have 9, the square root of 9 over 2, equal to 1 plus minus 3. Square root of 9 is 3 over 2. Now if you want to see the two independent answers, you'll say x is equal to 1 plus 3 over 2, or x is equal to 1 minus 3 over 2. What's 1 plus 3? It's 4. What's 4 divided by 2? It's 2. So x is equal to 2, or x is equal to, what's 1 minus 3? Negative 2 over 2. So x is equal to, negative divided by positive is negative, and then 2 times 2 divided by 2 is 1. They are our numerical values. They are rational. X is equal to 2, x is equal to negative 1. These are our numerical values that they were looking for when k is equal to 1. If k is equal to 1, it means substitute k in the place of the roots that you had found in the previous question. Then you simplify, guys. You simplify. Substitute, simplify, substitute, simplify. And when you substitute using brackets. When you simplify, you make sure you follow the procedure, right? Don't jump steps, so that you can then be led to paradise, to the answer that satisfies, that basically is correct. Are we guys, are we feeling a bit confident, with nature of roots? Is there a air of confidence that's besetting or falling upon your soul? Okay, not too shabby, hey? Not too shabby, hey, Rod? Not too shabby, hey, John? I hope it's not too shabby, guys. Hopefully it's the sense is being sensed. The making of the sense is there. Okay. Now look at this one. The next question. Very interesting. Very interesting. Determine the values, not just value, but values of K for which the roots are equal. This is a question that is different from the two types of questions that we had dealt with that pertain to delta. Remember, the first question that pertained to delta was discussing the nature of the roots. We saw how we do that. The second question was prove or show that the roots, and they even tell you how they are going to be given a certain condition. So it's a matter of just doing the calculation, following the same steps as the question above. It's just that delta gets expressed in terms of a variable instead of it being expressed in terms of a numerical value that you comment on for delta and the roots. Now you have to actually get an expression which you have to analyze, look at the stipulated conditions, and then make a judgment, and then comment delta and comment your roots. You see, it's also there's those dynamics. Now here, right? Okay, then obviously we did these questions where it was just straightforward solving for x. It's just that a little bit of spice in that when we solve for x, we're supposed to solve for x in terms of another supporting cast variable. There's the main variable with the main character, like the Goku of Dragon Ball Z. There's the main character, which is x, and then there is the Vegeta and the Freezers and the Cells and the Gohans, which are basically supporting cast. All right, yeah. So we need to just know that difference, yeah. Okay, you could say even in soccer there is your main character Orlando Pirates, and then there's the supporting cast Kaizer Chiefs, your other teams. All right, 4.3.3 determine. So basically we saw these two, how we do those questions. Now there's this one, which is basically the third type of question that involves just delta or the discriminant. And I want you to take note what it's saying. Determine the values of K. Stated in other ways, they usually say for which values of K. This is other wording they tend to use. Here it's saying determine the values of K for which the roots are equal. Now guys, this one is talking about roots that are equal. So there is a for which value, or there's a sense of determining the values of K, but then there is a condition that basically you are supposed to adhere to. So the condition in this situation is that the roots are equal. Now you should know what that basically means for delta. When we say the roots are equal, what does that mean for delta? All right, because here in this type of question, we are going to set up an equation, but it will be based on the condition. There's no ways we are going to get these values of K unless we use this condition here to set up an equation and then solve for K. So there's two aspects to this question. We understand we need to solve for K. That we understand very well. But then the condition, okay, leads to our setup And it can either be a linear equation that you set up, okay, where you get one solution, or it can be a quadratic equation that you end up setting up, or if it's not any of these two, then it can be a linear inequality. Linear inequalities? Yes. Linear inequalities, guys. Or if it's not linear inequalities, it could be quadratic inequalities. So you find yourself setting up using the condition, either finding yourself setting up a linear equation, or depending on the condition, you set up a quadratic equation, or depending on the condition, you end up seeing yourself setting up a linear inequality. Guys, linear inequalities were done in grade 10. They were compound linear inequalities, and they were just straightforward linear inequalities. There was not much stress to them. Then there's quadratic inequalities. Quadratic inequalities are done in grade 11. You start them in grade 11, all right? And then in grade 12, you sort of like obviously do what you were doing in grade 11. So it becomes so important for you to be someone who is capable of doing the inequalities, whether it's quadratic or linear, the equations, all right? Now, let us explore some conditions before I go and answer the question. I'm going to answer the question, guys, but for me, it's important for me to lay down the foundation so that if you get or you find yourself running into a different scenario than this one, this is one example, then you can be equipped to answer. I'm asking again, as far as delta, when we say the roots are equal, delta is what? Please, comment section, guys, just tell me. If I am saying the roots are equal, what is the condition for delta? Delta is what? The minute roots are equal, we are saying delta is? I need you guys to talk to me. I need you to talk to me. Haskido, thank you so much. You are too kind. The generosity in that comment speaks volumes, and I really appreciate it. It speaks to the person that you are, and you are very kind. Thank you so much. That you are enjoying this and loving the style of teaching too. I'm happy. That makes me happy. You know, it's in this moment that I wish, I could just have someone one day just throw me that galaxy that's in my gift gallery that I've never gotten in a live lesson. Hopefully in the future, it doesn't have to be today, but it would happen. Yeah, because those comments that you are saying, that comment, my guy, that you just posted there, it drives me crazy. It makes me happy because it makes me feel like I'm doing something, and that drives me crazy. Thank you, guys. You are 100% correct. Okay, you said when roots are equal, it means delta is equal to 0. I love you for saying that. Now let's say that the question did not say roots are equal. What if the question had said roots are non-real? Okay, you understand what it means when roots are real, roots are equal. It means delta is equal to. Had they said roots are non-real, what does that mean about delta? I'm talking about setting up our equation using delta. But had they said roots are non-real instead of saying roots are equal, what would we have said about delta? Delta is, if they said roots are non-real. Mohlala, JT, Haskido. Thank you, guys. Mohlala, you're 100% correct. Haskido, you are 100% on point. Yes. Had they said delta, had they said roots are non-real, then we would have said delta is less than 0. Remember, guys, when the roots are non-real, and we are told that that is the case, then we understand that delta is less than 0. That is the condition we are going to use. Had they said roots are real, what would we have written? Had they said roots are real, what would we have written? what does that mean about delta? I'm talking about setting the equation, guys, and you need to understand this language and interpret delta accordingly, so that when you set up correctly the equation. Otherwise, flames, got the flames, good people. When they say roots are real, what does that mean about delta? Okay. Gaziti, I see what you're saying. You're saying greater than 0. Bontle, you're saying real numbers, but you're not telling me about when they are saying roots are real. What does that mean about delta? Guys, you see, when roots are equal, what does that mean about delta? It means delta is equal to 0. When roots are non-real, what does that mean about delta? It means delta is less than 0. Now I'm saying, when roots are real, what does that mean about delta? Come on, guys, please. When roots are just real, what does that mean about delta? Okay, but let's say greater than 0, yes. Okay, I'm waiting to finalize my answer. I'm not going to jump to finalize the answer. I'm waiting for other people to comment. We can't be alone here. Sibonga konke Kalishwayo says delta is equal to 0 for when roots are real. Okay. I'm waiting. One more comment, guys, from someone. Then maybe I'll finalize it after the last comment. Okay, guys, here is the actual answer. If they say roots are real, it means delta is both greater than or equal to 0. Yo, guys, take note of this. I plead with you. If they say roots are real, you must say delta is greater than or equal to 0. If they say roots are real and unequal, what do you say? What is the condition for delta? Speak to me, guys. I hope you are jotting this down for yourselves. Okay, look at the question. Determine the values of k for which the roots are equal. Well, I want to solve for k, but how are you going to solve for k if you don't know what roots are equal means for delta? What does it mean when they are saying roots are real and unequal? Kibutsa ni. I plead for your answers, guys. Please. Real and unequal. Real and unequal. What does it mean for delta? Gaziti is saying greater than 0. What does everybody else have to say? Yes, Gaziti, let's stick to that, bro. Delta is greater than 0. Okay? Because they are saying real, but then they are saying and unequal. So we can't put the equal sign. We can't put the equal sign as well. Okay? Does that make sense, guys? It simply means we need to say that it's real. Alright? But if they are saying real and unequal, then we don't put the equal sign to accompany the greater than 0. Then the last thing I want to ask, what about real and equal? This is kind of like a trick question, but let's see if people can actually satisfy the hunger. If they say real and equal, you'll be shocked with this one when we write it down. You'll be so shocked. Haskiro, bo 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 bo, Haskiro. Askido, you are the one, brother. You are the one. That question mark needs to be, changed, and you must include an exclamation to showcase that you confidently have command over your understanding, and you know for sure what it means. So roots are equal and roots are real, and equal means the same thing. The minute, guys, there's equal, you must just know delta is equal to 0 alone. You don't mix it with anything. So please, guys, take note of the conditions, because when the question is being asked, the conditions get stipulated, and then someone has difficulty in setting up the appropriate equation. All right. So do you understand why I'm saying that you can, if let's say they had said not roots are equal, had they said roots are real, then you know that the condition is greater than or equal to 0. And there are two things. It's either you're going to set up a linear inequality or it's going to be quadratic, because greater than or equal to 0 lead you to an inequality. If the roots are non-real, that will either lead you to a linear inequality or a quadratic inequality. If the roots are real and equal, that's an equation, my guy. That will either be a linear equation or a quadratic equation that you are going to be led to. So do you see the significance of knowing the conditions? Now let's go and look at how do we answer this question. So first thing, they say determine the values of k for which the roots are equal. Okay, now I am going to show you something, but before I show you that, let's just take it from the top. Let's just be ignorant and go and take this from the top, from the original equation. Consider the quadratic equation. If I decide to take that original equation, and I'm going to show you other things as well. Kx squared minus kx is equal to 8. Do you see that, guys? We seeing that well? Are we good? Then what you do, you write the equation in standard form, of course. Okay. Then you identify a, b, and c. A is equal to k. You guys have done that already. Just want to... All right. So it's standard form, identify a, b, and c. It seems like we are moving sort of like in the same similar trend with the nature of roots questions and the show that or prove that the nature of roots question. So this one as well, because it's saying determine the values of k for which the roots are equal. Right. Once we get here, guys, step number 3 has to do with go and look at the condition. So they are saying determine the values of k for which the roots are equal. What does that mean? Okay, it means delta equal to 0. This is part of you setting up your equation. So you are going to say for equal roots, you sort of like stipulate that for equal roots, delta is equal to 0. Had they said the roots are non-real, you would have said for non-real roots, delta is less than 0. Had they indicated for roots are real, then you would have said for real roots, delta is greater than or equal to 0. Had they said anything else, roots are real and unequal, then you would have said for real and unequal roots, delta is. You see what I mean, guys? So yes, we standard form, we identify a, b, and c, right? That's step number 1. Step 2, identify a, b, and c. Step 3, we use the condition to set up either our equation or inequality, and we compare or use that delta to basically have that set up. Now, step 4, I'm sure now you know delta mos is b squared minus 4ac, which is obviously equal to, you are going to write b squared minus 4 is equal to 0. I think now for 4, you can substitute. But you substitute understanding that whatever you substitute has to be equated to 0 because you are on your way to solving the what? The equation. Now there's something I want to sensitize you to. You do this b squared minus 4ac. Alright, that's negative k times k times negative 2 is equal to 0. What do you get? K squared. You remember, guys, that we did this. Negative 4 times k times minus 2, it's plus 8k is equal to 0. Right? Substitute 5. Equation or inequality standard form. Get the equation or the inequality in standard form. 6. You solve. Solve in the way that you know an equation that is quadratic should be solved. Okay, once you're in standard form, we factorize here. Then after factorizing, 0 factor law. So k is equal to 0 or k is equal to negative 8. There, guys. They said that determine the values of k for which the roots are equal. Well, for which the roots are equal, the values of k are equal to 0 and or negative 8. Okay. Now, I just want to bring something else to your attention. Remember that the first time you were able to actually have a semblance of what delta is, you remember when you were solving for x, but you wanted to get your x value in terms of k. I just want to bring something to your attention that you may have not seen. And I want you to see that and never not see it again. They were there. This was your root, right? You had your roots actually given to you to show, right? This section here, this underneath the square root, what does it represent? What does this expression underneath the square root represent? Expression underneath the square root. Yes, guys. The expression underneath the square root, k squared plus 8k, represents delta or the discriminant. Thank you so much, Nozi and Gazi. Beautiful stuff. So proud. You make me so happy. So we could have, instead of going through all of this trouble again for question 4.3.3, you could have just said, started here and just said for equal roots, right? Delta is equal to 0. You just go and harvest the k squared plus 8k. You write it there and you say equal to 0 and you just solve. So guys, we literally could have said, instead of doing all of that, you would have gotten all your marks, guys, because you would have just answered the question based on the roots of your equation. This expression underneath the square root represents delta or the discriminant. So you could have harvested that k squared plus 8k. Take it and go and write it in the place of delta. It directly replaces delta. So you could have literally just gone ahead and answered this question by saying for equal roots delta is equal to 0. You jump and you go straight to k squared plus 8k is equal to 0 because that replaces delta. K squared plus 8k is equal to 0. Then you just solve the equation and that's it. That would have been 100% on point to do as well. All right, are we together here, guys? I hope we are. I hope we are together here, guys. I hope you're really understanding this. Okay. I just want to finalize then this. Had they said for non-real roots, of course that changes the condition. It wouldn't have been delta is equal to 0. It would have been delta is less than 0. Okay, I'm just looking at another scenario. If this question had said determine the values of k for which the roots are non-real, then we are talking about a different condition altogether. Delta is less than 0. And I'm just considering that for another possible way in which they would have asked the question and presented the condition. Then we would have gone and harvested that k squared mos plus 8k because it represents delta, and then said less than 0. When you are here, you use the same method that you know when you are solving a quadratic inequality. Don't all of a sudden become someone who's doing something that you've never done before. A quadratic inequality is solved in a certain way. Now, don't not now use that certain particular method. The quadratic inequality must be in standard form. You then factorize. You then write down what we call your critical values. K is equal to 0 or k is equal to -8. You then represent your critical values on a Cartesian plane with a concave up parabolic function, where your smallest critical value will feature on the left as your x-intercept. Because remember, what is a critical value, guys? A critical value is an x-intercept, or in other words, it is a root of a particular equation. So had we been solving a equation, we'd have gotten k is equal to 0, k is equal to -8. But we, at this stage, since we have factored our inequality, we write our critical values as the direct roots of this particular inequality if it had been an equation. Those are our critical values, so that we can use our graph with the critical values represented to then use the stipulated condition for our factored place to then identify the answer. Remember, less than 0 means where y is negative. Where y is negative, because remember, less than 0 means something that is negative. But who is negative? The output. What is the output? The output is y. So if you look at this graph, it is positive. Okay, y is positive here above, y is negative here below, y is positive here above. Does that make sense, guys? But now we want to know where y is negative. So we know that y is negative. I'm going to shade or give the green color that this less than 0 means where y is negative, and that is below the x-axis but between our critical values. So two ways of writing this answer would be k, because remember, now we have to be very cautious. We are not saying x, it is the k variable which is now the main character for solving for k here. So we say k is greater than -8 but less than 0. 2 marks for that final answer. Or if you want to write your answer in interval notation, you could say k is an element of open brackets -8 to 0 open brackets. That's perfectly fine. That gives us our k values, whereby the roots of that particular, mean that the values of k for which the roots are non-real. You see? Yeah. guys, I really hope we have sort of like beefed up, our understanding there of nature of roots, and as a result we are becoming that much more strengthened and fortified in that understanding. Okay, so I'm going to give you this for your work, right? So that you can practice. These are practice problems for yourself. Tomorrow when I go in do the live lesson, I will go through the practice questions as you have done them. So hopefully you will do them so that you can check yourself as to like whether this live lesson you're able to understand, and so that you can apply your knowledge for these practice exercises on nature of roots. Then you will attend to them tomorrow when I go live. Wangwa. Hopefully wangwa. Yeah, man, because nature of roots it tends to be an elephant in the room, and it doesn't have to be an elephant in the room. Nature of roots can be something that can be quite enjoyable, if you ask me, and doable. So let's give ourselves a chance to actually, do it. Spend some time and do it. I'll be uploading the video, as I said. As soon as I end the live, I'll try and download it. It takes a while, and then I'll upload it there in the YouTube channel. Please do go there and subscribe. Yeah. And you can watch the live lesson in your own time, your own pace. So I'm gonna end the live lesson here, right? We'll continue, answer these questions, and then continue with the next bit of section for paper 1, like your functions and so forth. But I think, let's call it a night here. I don't want to be dragging this live on for too long. You're welcome, Gaziti. Welcome, my brother. Moshlala JT is like, when are you going to do Euclidean grade 11? Oh, Shem Moshlala, are you in grade 11? My kind Moshlala, you are in grade 11. Yeah, man, let's see what happens tomorrow. Let's see, because it's likely that tomorrow, I might try and go live a bit earlier, so that I don't interfere with this continuity of the paper 1 aspect. So maybe let's see if I can't do that tomorrow. Let's see if I can't do that tomorrow with you guys, the Euclidean geometry. But not in the time, because I think this 10 to 12 time I'm going to continue to use with doing the paper 1. Let me try and fit in the Euclidean geometry maybe a bit earlier. So just make sure that all the notifications that are relevant, that it will allow you to see me when I go live, you make sure you click on those things, so that when I go live your notification comes in and you can come through. We'll see. Just that I do have a day that's busy tomorrow, but we'll see after 4, after 5, if you can't do that. Okay, thank you for your kind comments. You guys are very kind with your comments, really appreciate it. Gwande kwetu, Simashaba and Gaziti, you guys are kind, very generous with those comments. Very generous with those comments. I really appreciate it. That you would think that, all glory be to God all the way. One way for me. It's all glory be to God. Otherwise, let me see you. Let me love and leave you. Thank you so much, guys. You are really beautiful. You are great. You are beautiful. Okay, sorry guys. I think somehow I was unable to end this live. I don't know how, but I ended